Electric Motor Division, General Motors Corporation, Maintenance Instruction 4110, Revision B, Fuel Soak Back Pumps. Introduction: fuel oil. Some oil pumps supplied with a diesel engine for the adequate fuel for operation of the tanks with accomplishment of the positive displacement rotating or internal gear type pumps, which mechanical seals. These same type pumps are used for the turbocharged engine of the pump, lubricating oil with the turbocharged bearings prior to engine starting for a charger bearing for a time period to remove the residual heat for the engine with a shutdown with the two different manufacturers supplied for these pumps. Tuthill and Viking. The quality of the oil needed with a particular application determines which pump it will be used. Ratings maximum pumping capacity at 1200 RPMs. Tuthill 2 to 3 gallons per minute, 4 to 6 gallons per minute. Viking. And locomotive application: fuel pump is driven by a small electrical motor, having the other case with the marine industrial with a driven directly by the diesel engine. Later, instant with a separate with a pumping pipe. Priming pump is required to provide engine sufficient fuel for the starting purpose of the pump is used with the soak back pump. It is always driven by an electrical motor. Since Tuthill Viking pump is different somewhat in construction, specific instructions pertaining to each of them are provided in instances where no particular pump is identified, but the information will pertain to both pumps' operation. The operation of both Viking and Tuthill pumps is based on the internal gear pumping principle. The principle relies on the use of the rotor idle gear, crescent-shaped portion cast integral with the cover figure 1. Thus, the only two moving parts are reasonable. Further, the actuating pump is applied to the rotor transmitted to the idle gear, in which it meshes the space between the outside diameter of the idle gear. Inside with the diameter of the rotor is sealed by a crescent. When the pump is started, there's an increase of volume as if deep in the idler rotate come out of a mesh that creates with a particular vacuum, drawing oil into the pump of the suction port, but the oil then fills the spaces between the gear teeth. As the pump shaft rotates, the oil is trapped between the teeth of the motor idler and is carried past the crescent portion of the pressure to the pressure discharge side of the pump. With the teeth once again meshed and pressure side of the oil is forced from the space out through the discharge port. Our figure 1 shows the gear pump orientation, suction, discharge ports, body, rotor, crescent, and idler. Caution is very important that the old model Tuthill pumps are mainly driven with the direction of the arrow stamped on the pump by the Viking, and the new Model 2 Tuthill pumps are not so simple with the direction of the rotation. On all pumps manufactured prior to 1974, there is a passive suction part with the pump to seal with the assembly so with a partial vacuum is created with a shield with which with a hole for the seals to put together with shift with the pump rotation reverse. On the old style Tuthill pumps, there would be pressure on the seal, which will force the seal out of its seat as the pump pressure increases. On the pumps manufactured in 1974, there is a passive of the pressure part of the pump to seal. Some of the construction enabled to easy detection of faulty seal with a visible leak oil seal. Seal is a device to prevent leak of between the pump body rotating shaft. This is accomplished provided with a perfect smooth with the surface of the bowl shaft. The pump body with the clearance of it so small that the resistance to oil flow is great enough to prevent oil from leaking out of the air entering the pump body. The old model Tuthill pump figure 2 employed with the rotary seal with which trim of the shaft. This is assembly attached to the shaft with a copper washer, which, when compressed by a hex seal with the nut, prevents oil and air from leaking down with the shaft of the pass. The seal with a flexible diaphragm incorporated in the seal is a spring loaded to control the tension of the shield face. Leakage is prevented in the Viking pump figure 4 and the new model Tuthill pump figure 3 by a seal which rotates the shaft of the ride. It rides against the gland assembly of the carbon seal. Is secured with the shaft of the mini with the two notches of the carbon seal, which made the two corresponding tangs on the bronze cups of the seal. Assembly the shaft of the seal with the secured with the seal assembly by the neoprene seal, which is internal to the assembly, which is press fitted onto the shaft. Since it is provided with a low spring washer push of the seal against the gland body, the entire seal assembly contained within the pumping of the packing nut. Both carbon sealed neoprene seals within the sealing assembled to prevent oil from leaking around the shaft, while gas on the gland assembled the compressor of the backing nut prevents oil from leaking between the gland and the pump body. Maintenance pump should be to remove the surface and recondition the intervals prescribed in the application by the scheduled maintenance procedures. Alright, and it shows 1 cover screw, 2 the pump cover, 3 idler shaft, 4 cover gasket, 5 idler, 6 rotator, 7 the rotor shaft, 8 shaft pin key, 9 woodruff key, 10 pump body, 11 motor rotor bushing, 12 lead washer, 13 house plugs, 14 seal assembly, 15 felt washer housing cap, and then it shows all the parts expanded out on the top. Procedure for the disassembly inspection replacement of the worn parts assembly testing covered below. The disassembly. Hill pump old mounted with a shaft seal figure 2 of the place pump with a device with a so that one jaw grips the cross of the 2 port that do not tighten excessively with the pump housing may be distorted. 2. Remove the housing cap with a special spanner wrench. 3. Split the flat washer off the shaft with place 1 wrench on the hex seal and another wrench across the flat over the bottom of the pump shaft. Keep the shaft of the turning while loosening the hex back off the hex nut 5 and 7 the turn. 6. Remove the pump from the device. 7. Carefully grip the hex seal with a nut on the device. Pull oil the seal shaft as one assembly. 8. Remove the pin key from the shaft using a small pair of tweezers. 9. Inspect the shaft wherever the pin key enters in small with the burr. For the interfere with the removal of the housing plug, use a small file to remove the burr and necessary. 10. Place pump and device. Remove the housing plug with a special spanner wrench. 11. Place matching marks on the cover body of the pump to properly reassemble and remove the 8 cover cap screws. Then remove the pump cover. 13. Remove the rotor and idler. 14. Inspect the pump connection for wearing and scored surfaces. Hill pump new model figure 3. Place a pump device over the jaws grip ports of the port flange. Do not tighten excessively as the pump housing may be distorted. Shows 1 cover screw pump cover idler shaft cover gasket idler rotor pump body retaining ring seal assembly housing cap and new model Hill pumps exploded cross section view. 2. Remove the housing cap with a special spanner wrench. 3. Remove the seal with the housing cap. 4. Remove the shaft seal stationary bushing from the inside of the housing cap. 5. Remove the other half of the shaft seal from the shaft. 6. If there's a snapper ring under the shaft seal, remove some of the pumps. 7. The snap at the end of the rotor shaft that do not require snap ring to position the shaft seal. 7. Remove the cover cap screws with mark the pump with the cover body for the reapplication. 8. Remove the pump cover. 9. Remove the rotor and idler. 10. Inspect the pump components for the wear and scored surfaces. Viking pump figure 4. Place the pump in a vise with 1 jaw gripped with the 2 ports. Do not tighten excessively. Pump housings may be distorted. Remove the packing nut using a hook, spanner, wrench. Carefully remove the gland assembly with a carbon seal. 4. Place matching marks on the cover and pump of the body for the proper reassembly. 5. Remove the 6 cover cap screws. Then remove the pump cover. 6. Remove the idler. Alright, figure 4 shows the Viking pump exploded in cross-section view. Cover screws, pump covered idler, shaft cover, gasket, idler, rotor, shaft, pump, body, thrust washer, load spring, sealing assembly, carbon seal with gland assembly, packing nut, and woodrow key. 7. Carefully pushing the shaft of the pump until the rotor extend with the arm of the pump body, then carefully grip the rotor and pull the shaft completely out of the body. The shaft is removed. The sealing and assembly, load spring, thrust washer will be pulled off the shaft, the remaining in the pump body. 8. Remove the sealing assembly, load spring, and the thrust water from the body. 9. Inspect the pump components for wearing and scored surfaces. Inspection of the pumps. Individual parts of both of the type of the pumps. Inspect for the damage of the keyway with the end of the rotor shaft must be in good condition. There must not be any groove with a deep scratch in the following surface. The inside the diameter surface of the housing, seating surface of the rotor, outside the diameter of the rotor, and face of the rotor, outside of the diameter of the idler, both faces of the idler. 6 for the two surface of the idler, rotor, 7 inside surface of the pump, including surface and crescent. Rotor assembly should be positioned near the housing. Check for the clearance for the bearing of the shaft that must turn freely without detectable side play. But the side play requires replacement of the housing shaft of the bolt with the containing limited clearance between the rotor of the housing of 2,000 inches to the Hill pumps and 5,000 inches to the Viking pumps. Bushing, if the bushing in the 801, 7, and 806 old model Hill pumps are positioned within 3/32 of the oil groove within the suction side of the pump, the bushing of the new model Hill pumps must be positioned with the oil groove away from the pump ports. Other bushing assembly must freely turn with the idler or pin pump cover without any detectable side play. Obtaining the correct end clearance for the rotor Viking pump 1,000 to 2,000 inch by adjusting the thickness of the cover gasket with the result of the rotor shaft turning freely without any detectable end play. It is done without installing seal assembly. Gaskets are added and removed until the rotor is pushed back and forth. No end of the play. The detect with the remainder of the pump may then be assembled. It must meet with the torque of the requirement listed and with the testing instruction. Obtaining the correct clearance for the rotor and the Hill pumps 1,000 by adding 1,000 from the spacer between the rotor and bushing and so the pump cover and gasket, tapping the bushing until the rotors and light. Disassemble the pumps and remove with 1,000 inch spacer. Reassemble the alternate, but the spacer could be omitted with the cover of the gasket replaced with 1,000 inch thicker gasket using the same procedure outlined above. Our new seals then install the spring over the model for the Hill should be compressed 40,000 for the inch for the seal with the Viking. With the new model Hill pump should be compromised approximately 3/16 of an inch. Bronze bushing and the seal nut with the Tut Hill pump should be either refaced or replaced. Assembly with the pump Tut Hill pump old model with metal shaft seal figure 2. 1, install with the idle rotor and the pump body. 2, install with the cover gasket. If the pump has lost capacity with the thinner body gasket, maybe either the reduced acceptable clearance should be 1,000 inch. 3, install with the cover idler pump being sure that the alignment of the matching marks made before the disassembly. 4, install with the housing pump body and be sure of the lead washer in place. Assemble the parts of rotating seal before placing the pump and shaft with one part of the seal need replacement. Entire new seal assembly should be used, not compressed copper washer. 6, test seal of the shaft that should be free from the binding and be able to slide freely for the sail over the faces. Make contact, install pin key with clean surface deliberately with great care to eliminate dirt. Inspect all seal assembly so faces in contact. 10, compressed spring in the seal assembly. This is done by pressing on the hex seal nut. Amount of movement that should be 40,000 inch will produce the 7 pounds of the spring pressure. There no means of available to do the measure 4,000 inch compression. Press on the hex seal nut until the bottom, then release a few thousand of clearance. 11, hold spring compressed and tighten the hex seal with the nut blocks of the seal assembly to the shaft. Use the wrench on the shaft so with the hex seal nut and tighten screw the install with the flat felt washer gasket housing cap. Be sure the gasket is under cap. 13, place small quantity of the light lube oil in the pump body with the internal lubrication. 14, refer to testing instructions. Hill pump, new model, install idler rotor pump body install. 5, thousands cover gasket installed with the cover over the pump housing. Be sure that the alignment of the matching marks for the during the assembly. 4, rotor must be freely with the cover applied with the rotor. Does not freely remove 1,000 inch gasket with the tightened cover. Reapply gasket. Rotor should be turned freely. Install a snapping ring shaft seal with the rotor. Issue that it does not have the step to locate seal. 6, apply portion of shaft seal with the spring of the shaft. Apply the spring end of the way with the end of the rotor shaft. Apply stationary bushing in the inside of the housing cap, the lap surface toward the opening. Carbon seal rides on the lap surface of the stationary bushings. Apply the new seal with the housing cap. Apply the housing cap down housing. Lubricate pump rotor idler with light lubricating oil. Provide with the initial lubrication. Refer to test instruction. Viking pump. Place pump of the vise. Disassemble the grass rotor. Push shaft with the rotor housing into the shaft housing. Place idler shaft in the cover. 3, place cover the proper gat and the skid thickness idle over the housing. Be sure that the alignment of the matching mark for the cover of the housing, which will be made before the disassembly of the pump's locating pin with the notches, which provide alignment during assembly. In this case, the matching with the marks are necessary before placing cover the necessary with the determine the thickness of the covered gasket. Need to allow the shaft to rotate freely with any of the detectable play. But this was outlined in inspection of the pumps. 4, insert the spring, the thrust washer load spring on the shaft in that order. Caution, care must be taken not to forget with the install of the bronze thrust washer with a combination of load spring and the washer become with the rotate with the spring with the rules against the bronze bushing. Insert the pump body, serve as a wear plate with the washers left out with the sharp end of the spring will rub it against the bronze bushing and score with the severely. Carefully coat the shaft inside with the rubber label as a seal on some of the light oil with the carefully slip the carbon seal over the shaft, making sure the 2 notches fit when it hangs the sealing assembly. Place a small amount of light oil with the outer over the carbon seal face with the corresponding seal over the face for the gland. Assembly. 7, clip slip of the granite assembly gasket off the shaft and sealing face. The 2 gaskets are required for the working length of the seal. 8, place the packing nut over the shaft tighten with a compressed gland gasket using a hook, spanner, wrench. Refer to testing instruction. Pump shaft rotation. Pump shaft on all pumps should rotate in either direction applicable to 5 inch-pound torque. Test parameters. The pump test speed with the inlet suction outlet pressure. Effect of the pump flow with reduce the number of variable. The following recommendation are made with the pump speed with the test should be with 1200 RPM with 3/4 horsepower AC with the motor turning with the pump outlet pressure for the inlet suction should be read as close as possible. The fuel oil room temperature 15 to 90 degrees Fahrenheit should be used 1 inch pipe should be used suction side with the pump. The device use the restriction suction line to the pump should be located as far as from the pump as possible. This should be a sight glass before the after the pump visual inspection for air bubbles. Pump should run at 1200 RPM with the direction marked on the pump. If the 15 minutes with a full oil flow, no restriction on the pump suction discharge. The run screws. Running surface is set with a new sealing against the mating system. On application new seal, some of the leakage may occur with the pump is first started. The seal, if properly installed, will adjust itself within a minute or 2. If the leaking will stop. Wait 15-minute run and complete with the pump should be tested output. Alright, pump output should be checked with a suction head at 10 inches mercury and with a pump at 80 psi pressure outlet with a pump. The fuel oil temperature should be 70 to 80 degrees Fahrenheit. Flow can be checked by any of the following ways. Weight of the fuel oil per time interval with a flow meter with an orifice, whichever meter must be calibrated with the fuel oil following chart. Give the pump part number, nominal flow vendor, maximum output. Alright, the 4 Vikings with a nominal flow, 3 Vikings with a nominal 4 at minimum flow rate of 3.8 gallons per minute. 6 nominal flow gallons per minute Viking at 1200 RPMs. Tut Hill, you have 3 Tut Hills at 1.7 gallons per minute, 1200 RPMs, and a nominal flow gallons per minute 3 Tut Hill at 2.9 gallons at 1200 RPMs. World style Tut Hill pump should have the same rating as a replacement reducer pump flow, probably cause excessive clearance in the pump selection test. With no restriction to the pump outlet, restriction to pump inlet until the selection becomes 25 inches of mercury. Pump is still flow with a limited amount of oil. The duration of the test should not exceed 15 seconds. Failure to develop 25 inches of mercury suction includes a suction leak. Exists seal leaks on the pumps built prior to 1974. Storage upon completion of the testing of the pump will not be used immediately. The pump port should be filled with the SA number 10, number 20, or oil plugged with pipe plugs or stoppers. Installation pump to the motor. Install the pump motor. Check with the coupling end clearance. Very important with the proper clearance to provide with the coupling between the 2 coupling halves. The center piece to prevent end thrust pump shaft, which in turn can be damaged. The pump covered both single to double pump equipped with a coupling which have the distance 1 and half an inch between the 2 coupling halves within the end plate with the motor armature taken into consideration. There should be 1/32 inch clearance between composition centerpiece 2 die cast coupling halves of the pump bolted in place with the motor armature pulled toward the pump with the shaft of the farthest position. 2 pump bracket bolts should be torqued 5 to 8 foot-pounds. A very common error to assemble the knot with an inch. Consider the end plate with the motor armature which may cover the end of the thrust arm of the pump shaft of the pumps are not designed to take end thrust toward the pump cover, and extreme care must be to prevent thrust in any direction. Installation pump over the engine. 1 unit full pump driven with the diesel engine. Instruction removal of the installation will be found with the engine with the applicable engine maintenance manual. Modification of all pumps manufactured in 1974 which were changed in corporate pressurized seal chambers. This means that the fuel pump shaft seal chamber is not being vented with the pressure port over the pump shaft seals. Failures not will result with the oil dripping from around in the rotor shaft. Previous production pumps have seal chamber vented for inlet suction port. In this case, shaft seal with the failures result of the suction leak, which very difficult to locate. Pacific Viking pumps have been furnished with 2 different idler bushings and heads. Prior to 1957, the pump had a long idler bushing extended outside of the idler to the end of the pump head. Head was counterbored to receive the bushing. Between 1957 and January 1960, the pump was furnished with a bushing in the same width of the idler, no counterbore in the head. It was previously allowed to install flush bushing idlers in the pumps to either flush over the counterboard head with the fixture. All the pumps may be rebuilt with extended idler counterboard head. Tut Hill pumps redesigned incorporated an improved shaft seal with the change will become effective summer 1974. Now he shows flash gear pumps, model number part replacement, old pump number part description. Alright, that was Electric Motor Division, General Motors Corporation Maintenance Instruction, Fuel Soaked Back Pumps, MI 4110.